Good morning, everyone. This is Sir Topper at your service. For today, we're going to discuss an ellipse. What is an ellipse? An ellipse is the set of all points P in a plane such that the sum of the distances of P from two fixed points in the plane is constant. Each of the fixed points F prime and F is also called focus, and together they are called foci. Let's have the definition of the basic parts of an ellipse. They have the major axis of the ellipse. It is the line through the foci. The minor axis of the ellipse, the line segment through the center, perpendicular to the major axis and intercepted by the ellipse. And center, the point midway between the foci of an ellipse. Vertices, the points of intersection of an ellipse and the line through the foci. The latus rectum or the focal chord of an ellipse is the chord that passes through the focus and the perpendicular to the major axis. So here is the illustration. As you can see, there is the point P here with the ordered pairs XY. Okay? When you move that point along the ellipse, they are the this of 1 and this of 2 is always constant. When we say constant, if you add the two, it will be the same all throughout. Okay? So let's have the standard equations of an ellipse with center at 0, 0. So number 1, it is the square over a squared plus y squared over b squared equals 1. Let's have the x-intercepts. It is the plus minus a, the vertices. Y-intercepts is represented by plus minus b. The foci, f prime is negative c, 0, and f 0, or rather c 0. And to solve for the c, and the a and the b, we need to use this equation. C squared equals a squared minus b squared. And the major axis length is 2a. The minor axis length is 2b. In this case, it is b is less than a but greater than 0. So this is the illustration of the figure. Okay? So there is the so-called f prime with negative c coordinate, and we have the f here, the other focus, with the positive c coordinate, and the endpoints there of the ellipse is negative a, in here is positive a, and the other part vertically, this is positive a, b rather, and this is negative b. Okay, so these are the basic parts of the ellipse. Okay, the other way around is this figure. This is horizontal. Okay, so represented by x squared over b squared plus y squared all over a squared equals 1. Always 1. The x-intercepts here is the plus and minus b, whatever the value of b here. Okay, and the y-intercepts positive, negative a, and whatever is the value of a here. And the foci, f prime is 0, negative c. The f is 0, c. And the same, we're going to use this one in order to solve for side c, a, and b. So we have c squared equals a squared minus b squared. So the major axis length is 2a, or twice the value of a. The minor axis length is 2b, or twice the minor axis length. Okay? In this case, the scenario is b is less than a but greater than 0. In this case, as you can see, here is the first focus, the other focus represented by positive c and negative c. In here, we have negative b and positive b. Upper is positive a and the lower is negative a. So this is the scenario of an ellipse having a center at 0, 0 if b is less than a but greater than 0. Okay, let's move on. Let's have this note. Both graphs are symmetric. Both graphs are symmetric. Okay. With respect to the x-axis, the y-axis, and the origin. Also, the major axis is always the longer than the minor axis. So let's have these examples. Sketch the graph of each equation, find the coordinates of the foci, and find the lengths of the major axis and the minor axis too. Okay, for letter A, 9x squared plus 16y squared equals 144. And letter B is 2x squared plus y squared equals 10. Okay, so in the first part, let's have the first example. 9x squared plus 16y squared equals 144. Okay, so we need to express the given expression with one coefficient of x and one coefficient of y. But take a look at this. The right side must be equal to 1. How? So whatever is the value of your right side without the variables x squared and y squared, you will going to make that as your divisor. So to reduce the right side to 1, we have 144 divided by 144, which is 1. So that's it. Then we have also what you did to the right, you need also to do that in your left. It will be 16 y squared divided by 144. And also 9 squared divided by 144. So by reducing this fraction, it will be y squared over 9, and 9 over 144 is 1 over 16. So this is now your basic equation for an ellipse. Okay, so it follows that we need to solve for the value of a. So this is the basic x squared over a squared. So therefore, a squared is 16. To get the value of a, so just extract the root. So we have plus minus 4. We need the two values because of the left and right and up and down. Okay. For your b value, b squared is 9. So take the value of b is by squaring that. So we have the square root of 9 is plus minus 3. So we need that also, the positive and the negative, because of the up and down or right and left. Okay, we need to solve for c. So we're using the formula for foci. C squared equals a squared minus b squared. By substitution, we have c squared 16, which is your a squared, 9 as your b squared, and simplify, we have c squared equals 7. But we need the value of c. So c is equal to the square root of 7. C is positive. Okay? C is positive. Remember that c is positive. Okay? So let's have this one. F prime is equal to negative 7, 0, and f is square root of 7, 0. So we need to take the left and the right, or the up and down for this. Okay. So major axis length is 2 times 4 equals 8. Where did we have that 4? So 4 is simply the value of what? The square root of a squared, which is a. So 2 times a is 8, and 2 times b, which is 3, equals 6. Okay, can you follow? So let's move on. So this is the illustration of the scenario. So this is the ellipse. It is a is what? Greater than b but less than 0. Okay, so this is your f prime, negative square root of 7, 0, and your f is square root of 7, 0. So here are your b's, positive, upward, negative, downward. And your a's, negative 4 here, and positive 4 there. So this is the graph of the ellipse. So let's have this one. So 2x squared plus y squared equals 10. So we need to make the right side equal to 1 and remove the coefficient of x squared 2 to make it 1. So how do we do that? So divide it by 10, the right side, and also the left side. So we have 10 divided by 10 is 1. Y squared divided by 10, so just copy. Then 2 divided by 10 is reduced as 1/5. So it will be x squared over 5. Okay, so this is the new format of the equation. So it is an equation of an ellipse. X squared over 5 plus y squared over 10, which is 1. Okay, let's get the value of a squared. So in here, the a squared is 10. Okay, then taking the square root of 10, it is plus minus 2.24. Okay, and here b squared rather is 5. Taking the square root of b is positive negative 3.16. We need those positive negative a, positive negative b. Okay, we need to solve also the c value using the formula c squared equals a squared minus b squared. Okay, to solve for c by substitution, we know that a squared is 10 minus the 5, which is b squared. So therefore, c squared is equal to 5. And taking the square root, c is positive. Okay, remember that c is positive. F prime this time is 0 negative square root of 5, and f is 0 square root of positive 5. So we need to have the both sides. The major axis is the same, 2 times a, where a is square root of 10, so it is 6.32. The minor axis length is 2 times square root of 5, which is the value of b. Then we have 4.47. Let's have the graph. Okay, so look at this. It's along the y-axis. So f prime here, the f, this is the b this time. This is the negative 2.24. This is the positive 2.24. This is the a, 3.16. And this is a negative a, negative 3.16. Okay, so let's have the other way around. Okay, so this time, let's find the equation of an ellipse. So let's consider the given condition. Find the equation of an ellipse in the form x squared over m plus y squared over n equals to 1, where m, n is greater than 0. Okay. As you can see, the m here represents what? The a squared. The n here is the b squared. Okay, in this case, if the center is at the origin, the major axis is along the y-axis. Remember that. If the center is at the origin, the major axis is along the y-axis. And condition number 1, you are given the length of the major axis, which is 20, and the length of the minor axis, which is 12. And for letter B, length of major axis is 10, and the distance of foci from center is 4. Okay, let's see. Let's take the first one. The length of the major axis is 20, and the length of the minor axis is 12. As you can see, the given equation is this. B squared is your m, a squared is your n. So the length of the major axis is twice a. So length of the major axis is 20. Okay, in order to solve for a, we need to divide it by 2. So therefore, your a is 10. And the length of the minor axis is given by the formula 2b, which is 12. Okay, so by substitution, in here, let's solve for b. So divide both sides by 2. So it will be 6. So at this point, we can have the value of a, which is 10, and b, which is 6. So by substitution in the equation above, in here, we can have x squared. Your b will become 6. Okay, copy the exponent 2. Copy y squared. And your a is 10 and copy squared. And simplify further, we have x squared over 36 when we have 6 squared plus y squared over 10 squared, which is 100. Then equate it to 1 because that is the standard form. Okay, so let's proceed with letter B. We are asked the standard equation. Okay, we don't need to graph. Okay, so look at this. You are given the length of the major axis, which is 10, and the distance of foci from the center. What is this? Okay, and the equation here is x squared plus over b squared plus y squared over a squared equals 1. So let's go back. What's the formula for the length of the major axis? It is 2a. From the given, it is 10. To solve for a, divide it by 2. So we have a equals 5. What do we mean by a distance of foci from center? This is the c squared equals a squared minus b squared. So remember this. A distance of foci from center is given by c squared equals a squared minus b squared. And by substitution, c squared is given as 4. So we inject c in here. So we have 4 squared. The a1 is the 5. Okay, but we don't know the value of b. In this case, we can solve for b. So we have, okay, transpose negative b squared to the left, so it will become positive, and the 4 squared to the right, so it will be 5 squared 25 minus 4 squared equals 16. To simplify, we have 25 minus 16 is 9, but that is b squared. So we need to solve for b, so we have the square root of 9. So take note, we are dealing with the value. Okay, so in that case, we already have the value of a, which is 5, the value of c, which is 4, and the value of b, which is 3. But in the equation, we don't need c. We need only b and a. So by substitution, we have x squared over the value of b, which is 3 squared, plus y squared over 5 squared equals 1. To simplify further, so we have x squared over 9 plus y squared over 25 equals to 1. Okay, so we have seat work here. Sketch the graph of each equation, find the coordinates of the foci, and find the lengths of the major and the minor axis. So a, x squared plus 4y squared equals 4. Remember to keep the right side equal to 1. So that will be your divisor to make it the standard form of an ellipse. Letter B, 3x squared plus y squared equals 18. Same ruling. So in here, you need to divide the equation by 4. In here, you need to divide the equation by 18. Okay, for number 2, find the equation of an ellipse in the form x squared over m plus y squared over n equals 1. Take note that the condition is mn is greater than 0. Mn values are positive. The conditions are, if the center is the origin, the major axis is along the x-axis. Remember that. It's along the x-axis. A, length of major axis is 50. Length of minor axis is 30. For B, length of major axis 16, and the distance of foci from center is 6. Okay, so with this, we end our lesson. Thank you for listening, and hope you can get something from my discussion. Thank you, and see you next time.